Okay, so the next question that we got on the menu today is, it's asking about the visible light spectrum, and we're gonna look for some definitions, wavelengths, and then we're also gonna talk about what makes things different color. Like I'm wearing a blue shirt right now. My walls are painted orange. There's red on the Canada flag behind me. Like, why do different colors even exist? That's kind of the question of the day, or question of the hour. Okay, so for the visible light spectrum, a visible light spectrum is visible light spectrum. This is a portion of the electromagnetic wave spectrum. So suppose we have the electromagnetic wave spectrum here. Here we have a low frequency. Whoops. A low frequency, and here we have high frequency. High frequency. So low frequency, we're going to look more like this, and high frequency, well, it's going to be a little bit more frequent. Okay, the visible light spectrum is only a subset of it, and lower frequency or higher wavelength, those are the same thing. High wavelength, and this is low wavelength. Lambda is wavelength. Yeah, and we'll see that more in the equations. But if we have lower frequencies than visible light, this becomes like infrared, and like maybe even into like radio waves. And this is all invisible. And over here, it's invisible as well. Invisible to human eyes, that is. Some animals have have infrared vision, and they can. That's why some animals are better able to see in the dark, because their eyes can pick up more infrared stuff. And infrared waves also are what powers like night vision goggles. So if you're trying to see in the dark, there's no visible light, but there still is a lot of infrared light that is around. And night vision goggles just transform, or it interprets those infrared signals and transforms them into visible signals so that we can better see in the dark. So yeah, that's just one application of infrared lights, is in night vision goggles. And yeah, in the invisible for higher frequencies, this is getting into like ultraviolet light, and then it also gets into like X-rays and gamma rays, and that tends to be higher frequency stuff. Okay, now within the visible light spectrum, we have our different colors, and this is difficult to draw. It's better if I look into something like this, a nice diagram that shows the visible light spectrum. Okay, courtesy of ThoughtCo. Thanks, ThoughtCo. Really thoughtful of you. So you can see, hey, it really does follow like a rainbow type of way. So if I'm gonna draw it out, like we got like red, orange, yellow, green, like blue, purple, violet. So you can kind of see why like infrared, and here is like ultraviolet. You can kind of see like they get their names based on which light they are the closest to. Like you go more towards the red direction, you'll get infrared. More towards the violet direction, you'll get ultraviolet. Okay, and then the the wavelengths that these occupy is going to be like this border right here, where you can pretty much see, is around 740 nanometers. And here is, or for wavelength, here wavelength is equal to about 380 nanometers. Now this is going to be different for different people. Like some people have certain degrees of color blindness where they're not necessarily going to be able to see certain colors. That's because the cone cells in your eyes are the ones that differentiate the wavelength of light that comes in, and some people have some people do not have the same ability or the same number of cone cells in their eyes that allow them to like differentiate different colors. Different animals as well. So for example, dogs don't really see colors as well as humans. It's more so they would have like a more narrow visible light spectrum for a dog eyes. Like these are for human eyes. But other animals, like I'm pretty sure butterflies, they're able to interpret electromagnetic information in a higher visible light spectrum from us. So they would see more infrared and more ultraviolet stuff if you were a butterfly. So yeah, and let's say if you want to know the relationship between wavelength and frequency, it's as follows. So wavelength is equal to velocity of the wave, meters per sec, divided by frequency. Or yeah, and another way that we could write this is frequency equals velocity of the wavelength. So lambda, this is wavelength, f is just frequency, and v is velocity of wave. In this case, it is c, which is equal to 3 times 10 to the 8 meters per second. Okay, so that is some fun stuff about infrared or visible light on the visible spectrum. And colors is just like different wavelengths will have different colors. So you change your wavelength. If you gradually reduce your wavelength as you start at red, you will see that you will fly through a rainbow and maybe find a pot of gold at the end of it. Who knows? Yeah. Fun stuff. Visible light. I see. Yeah, the above solution is good.